Hi friends, in this particular video I am giving you a brief idea about how 8086 is interfacing with various output ports. Okay, in the previous video I explained how 8086 is interfacing with 8-bit as well as 16-bit input port. Okay, in that case I am using buffer, whereas here let us see how 8086 is interfacing with output port. In that I am using latch. Okay, let us see. See here. So in 8086 we have two ports. Okay, generally if you consider 8086, it is communicating with two ports. One is called as a input port, other is called as a output port. So in the previous video I also explained the same diagram. So if it is input port, what happens? Processor receiving the data from the input port, call it as a buffer. Here, so data will be transmitting from the input device to buffer, then buffer to processor. So processor will receive. Whereas in the case of output port, now the name is latch. In the case of output port, what happens? So processor will sending the data to output device, then output device will sending data to other output port. See, now this is the output port, and the role of this output port is this output port receiving the data from the processor, and that receiving data will be transmitted to any of the output device, maybe printer. Okay, like that it will transmit data to other output device. So it's a reverse. Whereas here processor receiving, whereas here processor sending. Let us see what are the various output ports. The output port generally we are calling as a latch. Let us see here. Now coming to this one, here also same. Now here I am taking one latch. Here I am taking one latch. Okay, so latch is a output port, and the role of latch is it is having 8 input pins, call it as D0 to D7, and 8 output pins, call it as O0 to O7. So the latch will take data from the processor. Here lower byte data bus of 8086. Nothing but this latch will take 8 bits from the lower byte of the processor. Okay, then latch will transmit those 8 bits from O0 to O7 to LEDs. Here how many LEDs are present? L0 to L7, total 8 LEDs are there. And each LED is connected to resistance and voltage source. A voltage of value 5 volts and resistance of value 330 ohm. So these two are used to limit the current in the LED. So with the help of voltage and resistance, we can identify what the maximum allowable current in the LED. Okay, so now based on the information that is coming from the processor, the corresponding LEDs will glow. I will tell you briefly. See here, if you give O0 for example 1, then the corresponding LED will off. Similarly, whenever if any value, any O0 to O7, if any value is 0, the corresponding LED is on. So here LEDs are on, the corresponding bits must be 0. LEDs are off, corresponding bits must be 1. In latch there is a one control pin, call it as LE. Name is latch enable. So in the case of buffer, that is input port, we observe OE bar, whereas here LE. So when this LE is activating by giving 1. So here also we use one decoder. This is decoder. The role of decoder is it will provide two functions. One is it will give you address for this particular latch, and this decoder also activating the control pin of latch. So the control pin of latch is LE. This LE is activating by decoder, and also this decoder provides address for this latch. Okay, let us see in which way it is happened. See here, for example, in decoder also we have 3 input pins A, B, C, and 3 control pins G1 bar, G2 bar, and G. So and this decoder generates 8 outputs, whereas in this case only one latch, so one output is enough. Okay, one output, Y2 is one output. Like that it will generate Y0 to Y7. So when Y0 to Y7 are all zeros, your outputs are enabled means all zeros. When output becomes all zeros, only thing is by activating G1 bar, G2 bar, and G. So G1 bar when it is activating by giving 0, then only it will activate. So definitely my A3 must be 0. Similarly, when G2 bar is activating by giving 0. So when output of R is 0, all inputs of the R must be 0. Nothing but A4, A5, A6. These 3 must be zeros. Then only output of R is 0. 0 is given to G2 bar, then it will activate. Here A7 must be 1. Then only G will be activating. So G must be 1. G1 bar, G2 bar must be 0. Then only these 3 are activating. Then only output is enabled, and that output will be given to these logic gates. Okay, anyway, what are the logic gates here? I will explain. So in the case of input port, I mentioned here read bar. Here why I'm mentioning write bar means processor writing data to other device. That's why here write bar appeared. M by IO bar. M by O, for IO operation, IO bar must be activating. For that, M by IO bar should be 0. Then only we are selecting IO bar. So this is 0. For activating write bar also 0. Then only write bar is activating. So when write bar is activating by providing 0 during T2 to T4 time. So write bar 0, M by IO bar 0. Then what is output of R? 0. 0 give it to NAR here. Now output of one input of NAR is 0 from this. Now Y2, Y0 to Y7 all are 0. So Y2 is also 0. So both inputs are zeros. To make output 1, we are using NAR gate here. Because of NAR gate, if two inputs are zeros, output becomes 1. 1 is given to LE, then it will activate. Okay, like that we are activating. Here the ABC are connected to 3 input address lines, A0, A1 and A2. Okay, so in the case of buffer operation, nothing but 8-bit input port as well as 16-bit input port, we observed A0, A1, A2 should be 000 for 8-bit address purpose, 001 for 16-bit address purpose. Like that we have addresses in the input cases. 80H is the address for input port, 8-bit input port. 81 is the address for 16-bit input port. Okay, like that we have two ports are if you take. First input port address is 80, other input port address is 81. Whereas here just for a easy way, I will take another two. Another two means 82 and 83. See here 82H is the address of latch 1. Whereas if you take another latch is present, 83H is the address of another latch. So for that case, what happens? I am taking A0, A1, A2 with values because these 3 are inputs. We can give either zeros or ones. So here I am taking 0, 1, 0. Okay, so A3, A4, A5, A6 must be 0 in order to activate G1 bar and G2 bar. And A7 must be G. A7 must be 1. Then only G is activating. So A7 must be 1. A6, A5, A4, A3 must be zeros. And A0, A1, A2. Okay, I'm taking because 3 inputs are there. We can make 8 combinations. First 2 combinations for 8-bit input port as well as 16-bit input port. Now let us see other combinations. So 0, 0, 0 over 0, 0, 1 over for previous input port. Now it is 0, 1, 0. Then what is the address? 82H is the address of this particular latch. Like that we can identify what is the address. Here you remember one more important point is here how many address lines are present? 8 only. So 8 address lines are present and we are selecting IO mapped IO means. So it comes under direct addressing mode. IO mapped IO in direct addressing mode. If it is indirect addressing mode, okay, in the introduction part of IO operation I explained. So IO mapped IO operates in 2 modes, direct mode and indirect mode. If it is direct mode, we have 8 address lines. If it is indirect address mode, we have 16 address lines. So same diagram we can draw, just we A7 also keep same. Here after A6 you add A8, A9, A10 like that up to A15. Okay, A15 here. Okay, then we have left side A8 to A15 we get zeros. Then what is the equivalent value in that case if it is indirect? 2 more zeros are added here in hexa. So 0082 0082H is the address if it is indirect. So overall net address is 82 only. Like that we can modify same diagram for indirect addressing mode of IO mapped IO. Okay. So now let us see one program here. Our aim is here the following program glows the LEDs L0, L2 and L5. So what is our aim? We should glow L0, L2 and L5. So in order to glow L0, you already mentioned if you glow any LED, the corresponding bit should be 0. See, the L0 must be 0, L2 also I need to glow. So that should be 0 and L5 also glow. That should be 0. Remaining all are ones. Then those LEDs are off. What is equivalent hexa here? DAH. Okay. If you send a DAH data to output port, nothing but latch. Accordingly, latch will enable L0, L2 and L5 LEDs and disable remaining LEDs. Nothing but off remaining LEDs. How to write the program? So here move AL comma 0 DAH. Why I am writing 0 left side in the every time it is same. So whenever if higher 4-bit value is more than 9, we should write left side 0. Otherwise it will give you syntax error. Okay, so move AL comma 0 DAH. Then what is the next one? In the previous input port I mentioned in here because processor receiving the data. Whereas in the case of latches, processor sending the data. That's why we are writing out. 82H comma AL. AL already having which value? DA. Now the DA value is now moved to 82H. 82H is the address of your latch. Then latch understood that, oh, processor wants to glow lamps L0, L2 and L5. Accordingly, it will glow those LEDs. Then into 3. Like that, we can write program also. This is the diagram for interfacing 8086 with 8-bit output port. Okay, only one port, output port is present. If same way, let us see for 16-bit. Okay, 16-bit output port, 16-bit interfacing. means instead of 8-bit output, let us say 16-bit output. Okay, now see the other diagram. See the diagram once. Now this is so interfacing 8086 here, interfacing 8086 with 16-bit output port. Here how many latches we are taking? 2 latches. First latch, second latch. What is the role of first latch? First latch will receiving data from the lower byte of processor. The second latch receiving data from the higher byte of the processor. Like that latch D0 to D7 here. This latch receiving D8 to D15 data. Okay. Then output of the latch is transmitting to 8 LEDs here. Output O0 to O7 transmitting to 8 LEDs, L0 to L7. Other latch also another 8, L8 to L15. Okay, and all are connected with voltage and resistance to limit the current. Okay, in order to activate these 2 latches, one decoder is enough. Here also because of 7 address lines, it comes under IO mapped IO, that to direct addressing mode. Here also in same way I am considering A7 is connected to G, means A7 must be 1, then only G is activating, because G1 bar, G2 bar, G are the control pins, whereas ABC are the input pins. A0, A1, A2, we can select inputs either zeros or ones as per order. We can select next order. Similarly, A3 must be 0, then only G1 bar is activating. A4, A5, A6 must be zeros, then only output of R is 0. 0 give it to G2 bar, then it is activating. So here also A7 must be 1, A6, A5, A4, A3 must be 0 for activating G1 bar and G2. And A0, A1, A2 must be combinations here, 0, 1, 0. Okay, for first latch. 0, 1, 0, 1, 1 for next latch. Like that, we get 82H is the address of this one, 83H is the address of another latch. Okay, here also after activating these 3 pins, what happens? This output of the decoder Y0 to Y7 must be enabled. So that enabled means zeros, remember. Okay, that output will be given to NOR, one input to NOR. Okay, here also write bar must be activating, M by O bar must be activating for IO mapped IO. If it is memory mapped IO, we are connecting one NOT gate here. First we are activating memory, then because of NOT output is 0. Like that we have diagram for memory mapped IO. Anyway, we'll discuss memory mapped IO later. Now for IO mapped IO, now we are activating IO bar. For that we need to give 0. Here also 0. Then write bar is activating. Both are zeros. Output of the R is 0. Then 0 here. This is also 0. Output should be make it like a 1. We are using NOR gate here. That 1 will be given to LE. Then it will activate. The same 1 will be given to this LE also. So at a time both latches are activating. Okay, and address for latch, first latch is 82, next latch is 83, because each latch can transmit only 8-bit, but we have 16-bit, so we need 2 latches. For that, one latch address is 82, other latch address is 83. Okay, now here also, for example, processor wants to glow all the LEDs, L0 to L15. Okay, L0 to L15. How to write the program? L0 to L15 for in order to glow, O0 to O7, similarly O8 to O15. Nothing but all 16 bits must be all zeros here, all zeros. Move AX, now it is a 16-bit. 4 zeros H. Then out 82 H comma AX, because AX size is 16 bits, so it can allocate 2 locations, 82 and 83. Because of out instruction, what happens? Process sending data to other output port. Okay, so 82 nothing but address of first buffer receiving 0 0 lower byte value. Accordingly, it will glow 8 LEDs. And similarly, next address is 83, because of size of 16 bit, it will allocate 2 locations, 82 and 83. So 83H address receiving AH value. AH also for the value 0 0, because of 0 0 another 8 LEDs also glow automatically. Like that we can interface 8086 with 16-bit output ports. Okay, and these 2 latches, output ports nothing but latches. These 2 latches are controlled by decoder. So the role of decoder is it will provide address for the latches and also controls the turning on the latches, nothing but controlling the latches. These 2 latches are also controlled by decoder. Okay, right. So like that we can analyze how 8086 is interfacing with 8-bit as well as 16-bit output port. Okay. Okay, thank you for watching this video. So if you really like, please kindly share my video